Good morning, everyone. I'm Priya Ananthasankar. I have about 10 plus years of infrastructure and back-end engineering experience. I'm currently a principal software engineer at Microsoft. I want to thank DevOps Days Dallas for giving me this opportunity to share my learnings and my views on this topic. And speaking of views, these views are my own, does not necessarily represent my employer. So let's start. I did speak to the organizers a bit yesterday, and I think this is an audience where many of you are advanced and intermediate DevOps practitioners, and there could be beginners. So if you are an advanced or intermediate practitioner, you may look at this presentation and say, you have your aha moment. I have seen this before, but if you're a beginner, hopefully you can take away something from this talk. So why do we need timely migrations? Any infrastructure reaches its constraints. So over time, right? I'm not necessarily talking about ones that are not even cloud native. The ones that are cloud native too, services that are running for periods of time will have its constraints. And it requires a timely migration to avoid getting into this vicious cycle of technical debt, where upgrading a system evokes fear in your team and it reinforces the belief that change is futile, right? I got to rewrite this whole thing. Neglecting migration, when I say more like procrastinating, nobody wants to willingly neglect it, but procrastinating it leads to your team getting into this maintenance cycle, and it's hamster wheeling for a while, right? So it can be intimidating to migrate something that's been running in production for a while. That thing has been hammered, has gone through the wheel of fire with on-call, and it's faced a bunch of systems issues, and it's been hammered to work well. And for whatever reason you want to migrate, maybe something reached end of life, or you want to patch things faster, right? It's a serious undertaking to decide to migrate and move to a newer infrastructure. And as a service matures, it develops robust resiliency practices, right? And then, so how do you migrate? So that's when you get this resistance to, should I be doing this? So how do we tackle this, right? So we have this. What I'm going to talk about is this measured risk. So there is a methodology where you can proceed cautiously and with more services relying on foundational services that are serverless, there's more challenges, so that's another thing that I'll be addressing in this talk. So if I look at the methodology, I want to look at any migration exercise as an expedition. At least when I did it, it seemed like one. And what you do is you first chart the course, right? You say, okay, I'm going to start with an experiment, migrating A to B. Start with an A-B experiment, and then you identify a path, which is how you're going to roll out your migration across your entire service. And the third part is really the meat of my talk, which is how are you going to have this compass with you that consistently measures that you're proceeding in the right direction? And I have some ideas. I'm pretty sure for each service it's different, and everyone else would have other ideas too. So I'm interested to hear that post the talk. But what are we going to use to measure my migration? And finally, how do you reach the destination? How do you complete it? So that's how I want to structure anybody who's undertaking any sort of migrations. So with the A/B experiment, I think everybody here knows what an A/B experiment is. So there's a very high-level description of what it could be at the service level. So you can have a client, and as you see in this picture, you have a service API A, which is your good old service that's serving for a while now, and it's returning a resource from an infrastructure A, right? And then you have service API B that's returning from your new infrastructure B, and you set up this new infrastructure, and let's assume that this new infrastructure is serverless, and your service is dependent on something that's serverless, right? And then you have your new infrastructure B, or a managed service, I would say. And you could set up the A/B experiment at a client level and say, I'm going to send a portion of my traffic to the new service API, and so that I can start my experiment that way. Or you could actually put that A/B switching in your service itself and redirect to the old and new infrastructure so that your client's not changed too much. You could do it either ways. So that's basically, you set up your infrastructures, your new infrastructure that you're going to migrate to, you have a basic setup of it, and then you start throwing some of your traffic, right? So that setup is up and running. And then you identify a path, right? So you say, I have identified this A/B experiment, and I'm going to do it in my small usage region. So if there's regions that you have partitioned on the basis of your traffic, and you could just start with your small region and then move on to medium, large. Now this is the meat of my talk, which is like, now that you set up your path, okay, this is my plan. First 3 months, I'm just going to migrate my smaller region, and I'm going to see how it goes, right? And what are you going to do to measure how your migration is going? So the first thing that you could do is fallback, right? So your service could send a request to A, and it's always sending a request to your old infrastructure to serve, right? And your service could actually now send the request, portion of the request with your A/B. Let's say 2% of the traffic goes to the new infrastructure, and then it fails, right? For whatever reason. And then you fall back to A to serve, and then your service emits a fallback metric that you can measure with your favorite monitoring tool. You can gather those metrics, and even logging, look at it. So this is like, with very few traffic, you just start with this and you measure fallback. That's one of the things that you could lean on. The next thing that you should lean on probably is infrastructure health. And I'm not talking about the typical health that people like network connections or disk and all of that. It's more like design your infrastructure health metric or health API in a logical way, right? So what you're going to do is, let's say you have service API that's requesting any resource. It could be a VM, it could be a storage, and it's requesting, your service is requesting this from a managed service or something serverless. It's a black box, and it's returning you a resource. Is this resource going to be healthy till the end of its usage? Designing a health metric at a logical level helps. For example, you can look at a VM. Take a VM, and let's say you're serving an app or something, and you have some platforms in that app, in that VM. So you could also add a health endpoint in that platform that you can ping and determine that if your service is indeed healthy. So I'll tell you why this is important, because every unit's health, and if you are measuring the health of every single unit that your service is returning, and you are dependent on a managed service, which You know, one of the things about serverless, we all know this, is we lose flexibility in debugging and we lose flexibility in introspection for any serverless. You can't go, you know, that's one of the common cons as opposed to many of its pros, but people like to, you know, debug to the root cause and get to the root cause of issues, but so when you're in that situation, you just have to make sure that your service is healthy and you have the right health check. So make sure there is a metric that's representing the health of the unit of resource that you're returning. So if you're returning a bunch of VMs as a unit, if you're returning VMs and connections to those VMs as a unit, just make sure you measure the health of that one unit. And the second tip is something that is really useful. Have a zoom out view of how all of your things, that all of the resources that your service is serving to multiple customers, even at high scale, have a zoom out view of it to see any trends, right? And one of the things that could go wrong is a noisy neighbor issue. Many of you might have seen, some of you might have seen noisy neighbors where you have 10 VMs or 10 compute resources or anything, any resource. I don't want to be specific to compute, but you have anything running on a big node, and one of them is so much of it's taking so much of CPU, so much of resources that it's draining the other resources running in the same node. It's draining it, draining their capacity. So that's a noisy neighbor, and it could manifest in several ways. It could happen because somebody did an OS upgrade that kind of shut down the connections, or it could happen because there is one thing that is, it's crashing the entire node. So this is zooming out is a very good way to see if something like this is happening. So you have your infrastructure health, right, for each of your resources, and then you plot a graph, and then here's a scatter chart that is showing you that all of my resources are not completing its lifetime of 4 hours or 4.5 hours. It's just dropping, right? And you can see right away that there's something going on. You can work with the managed service or the other service folks to see what could be going wrong. And here's an example of when everything is fine, like when your noisy neighbor is eliminated, you just see that all of your, you can get a good zoom out view. This is just an example. You can design a zoom out view for your scenarios, however in whichever is applicable. It's not necessary, this is just an example. It's just when it comes to scale, right? When it comes to scale and when you have so many resources, you just want to look at overall how is my service doing. This is very helpful. And as I said, put some local health probes. It's not just because of, here I show an example of a VM and you have some connections inside and some ingress and egress, and you have a local health probe that could ensure that things are connecting properly. That could be one of the compasses that you can use to measure as you migrate, right? Now the thing is, when you migrate to A to B, this A and B, I made it very generic. It could change according to your requirements. And this is something we all know, I think, mostly with a cloud service, any kind of service API, when you request something from a managed service, it could be any managed service, you got to honor that service's service limits, right? So when you're migrating, that you are used to sending us traffic at a certain requests per second, or certain number of traffic, certain number of requests per certain duration, right? So you got to honor what the new service that you're migrating to, what does it expect? So just be mindful of it when you want to migrate to these kinds of serverless environments, and factor in retries. So you will be retrying it, retries are part and parcel of distributed system, and so you got to factor retries and make sure you're not storming with retries, and especially important in scale. It's not always your exponential back off is not like, it can just keep expanding, right? You can't rely on it all the time, but yeah, so this is one of the things to keep in mind. The other thing I want to chat about is scale limits, right? So every unit of infrastructure that you have has these micro units in it which are independently scalable. In today's technology, especially in cloud native, you have IP address limits. IP address is one of the things that is notorious, where you have limits for it, and there's also a lot of public documentation that says plan your network, and many of you might be network ops experts. Here you may know this, that you have to plan networks even in the service level. I'm not talking about the end user, like at a service level too, when you are serving someone, and how do you horizontally scale your service? That's important in a migration, and then you plan your plan for all these small elements that are independently scalable, right? Your subnets or your IP addresses are a good example. So, and you design your hosting unit. This is my unit of hosting, and I'm going to scale this way, right? So once you have all of these, let me actually go back to my previous slide. So you have all of these compasses that you have, just throw them into a dashboard, and then you could tune independent parts of it. So you could say, you could have a fallback metric that's basically, okay, I'm falling back n times. Now you got to go debug that and then see why you're falling back to the old infrastructure, and then you can make the necessary adjustments, and then slowly send a little bit more traffic to see if it's getting to 0 before you proceed to the next stage. So, and as scale increases, how your new service, how does your service fare serving out of a new migrated infrastructure? How is your service doing? So you could put it in a dashboard, and you could have a monitor, and this is your compass, right? This is what you're going to look at when you embark on this, at least from region to region, right? A good migration is one that has some kind of an end in sight. So what's your completion metric? When can you call it done? You could say your fallbacks are 0, and all the traffic is accounted for. It's not serving out of A anymore. There's always jitters if you have to decommission your old infrastructure. There's that jitters. So you have to ensure that your fallback is completely 0. Your traffic is accounted for, you have parity with the previous infrastructure, pardon the spelling issue there. So you have full parity with your previous infrastructure. As part of just determining parity, you may run into, some things that I was able to do in the old infrastructure is not realizable, like, I can't do it if I have to do it differently in the new infrastructure. Based on that, your compass will keep changing, right? So if you're connecting through a different ways, you're connecting to your infrastructure in a different way, and in the new infrastructure, it's you're no longer doing that. That might change your compass. So make sure you have full parity. You have a parity list, and then you can rinse repeat this process for all regions. Like you can just say move from a small to a medium to a large region, and then you can complete your migration. That said, these are like generic, maybe too generalized, and there are some specific examples here, but which I'm assuming is more like compute service, or I'm assuming like, I'm making some assumptions here, of course, but I'll be very happy to hear about your stories, and if you can contribute to some of your, what would you use as a compass if you're embarking on a migration journey? Everybody has to embark on it in their, in their DevOps career for sure, because as I said, infrastructures have constraints. With that, thank you very much. And if there's any questions, I can take some questions now, or feel free to catch me. I'll be around. Thanks everyone.